Hello everyone, welcome to this session on open access spatial data sources as part of the ongoing online training program on Introduction to Remote Sensing and GIS technologies using QGIS. In the first two sessions, you gained an overview of remote sensing and GIS technologies and later you were introduced to QGIS, Quantum GIS, a free and open source GIS software. You also learned about spatial data, which refers to data that has geographic or locational component and that it can be represented using vector or raster data models. In this session, we will explore some of the open access spatial data sets, both vector data sets and raster data sets, which you can freely download and use in any GIS application, including QGIS. We will look at publicly available and crowdsourced data sets such as OpenStreetMap and also data created by various individuals and organizations. We will also look at some of the authentic sources of data like Survey of India online maps, then Bhuvan portal of National Remote Sensing Center, India Waris Water Resources Information System of Ministry of Jal Shakti. Then we will also have a look at Bhunidhi portal, which was recently launched. And then we will also look at the global open access data sources like USGS Earth Explorer, Copernicus Data Space Ecosystem, NASA's Earth Data Platform, etc. This slide is about the importance of spatial data. Just to repeat, vector data represents discrete real-world features which you can see on the landscape. Ranging from say point data, for example rain gauge stations or hydrological observation stations, then to polyline features like river system or canal distribution system, roadways, railways, and then polygons which can be used for representing administrative regions or hydrological boundaries or catchments or basins. On the other hand, raster data are made up of grid of pixels, each containing a value representing the conditions for the area covered by that particular pixel. For example, all hydrological parameters, whether it is precipitation or soil moisture or evapotranspiration, they all vary from place to place in a continuous manner, and they can be better represented in the raster data format. So is the case with elevation data. Remote sensing and GIS technologies are no longer confined to scientists and research institutions as in the past. Because everyone has have got access now to computational facilities and the free software is available. And we even have cloud platforms such as Google Earth Engine and Microsoft Planetary Computer, which enable users to access data sets on the cloud and also the computational facility which is available at their data centers. So you just need to write few lines of code while connected to the internet, and you can access the data sets as well as the computational power to do any kind of analysis. So this enables the users to concentrate more on analysis part and spending little time on data preparation. We are in an era of explosion of open access data. There is lot of data, plenty of data, big data is available, and we have also have a open source programming language, Python being the prominent one, which can be used for analyzing such humongous data. And we also have many free and open source software tools which can be used for analysis visualization purpose, QGIS being one example. Earth observation data particularly is useful for monitoring environment in the context of climate change predictions, urban planning, disaster management, etc. Many of the space agencies, NASA of US and European Space Agency of EU region, they had made their remote sensing or Earth observation data freely available to the public. NASA, for example, has a system of distributed active archive centers, which are spread all through US and through NASA's Earth data login, you can access the data sets being distributed by these active archive centers. Similarly, European Space Agency earlier it used to have Copernicus Open Access Hub, and now they have changed it to Copernicus Data Space Ecosystem. Recently, the Indian Space Agency the ISRO has come up with Indian space policy, which was approved by the government. According to the Indian Space Policy 2023, it enabled we have access to the extensive archive of remote sensing data acquired since 1986 by our own Indian remote sensing satellites. The data has been made available through Bhunidhi portal. It is still catching up, and in future we may expect to have access to a lot of remote sensing data collected by our remote sensing satellites. Now we have many open access spatial datasets in vector and raster formats. We will start looking at some of them, starting with the vector data. Let us look at OpenStreetMap data. OpenStreetMap is created by general public and it is free for anyone to edit the data, create and edit the data, download it and use it for any purpose. It emphasizes local knowledge. Therefore, if you are especially looking for information at a very local level, like street data, buildings data, parks, etc., the data which is available can be quite useful. However, you have to exercise the caution because the general public has created and edited the data. Still, it has its utility. At some of the locations, there you may not be able to find the data because there may not be any user who has created the data from that particular area. The data can be downloaded from portals such as GeoFabric and the humanitarian OpenStreet map team. This GeoFabric is a German-based company. It is GeoFabric in German means geo factory. It promotes free geodata created by OpenStreetMap. And then this humanitarian OpenStreetMap team it has an export tool on its portal which can be used for downloading the OpenStreetMap data. It works in the area of disaster management. In QGIS, you can directly import the OSM data, OpenStreetMap data, using this plugin, Quick OSM plugin. We will see it in the session on vector analysis later. Now let us have a quick demo of OpenStreetMap portal and let us try to download and visualize some data sets. You can type this URL openstreetmap.org in the address bar and then zoom to your area of interest. If you are trying to create new data, edit existing data, it will ask you to log in. You can sign up using your email ID, and once you receive the confirmation mail, you can use your credentials to log in. And then zoom to your area of interest. In my case, I am looking for National Water Academy campus. So you can see the layers, map layers, and the map data which is already there, which has been created by other users, like all these buildings, streets, the canal here, and all the nearby residential localities. The building data has already been created by many other users. Only this morning I had logged in and tried to give names or added the field for these features, like this is the National Water Academy official building in the main campus. I had given the name here and also to the guest houses on the other side. So you can if you want to edit any of the data, you can check this edit button. And then go to any feature, like this is the feature, building feature. You can select the building feature, and you see I had created the name and I had given the address. I can even add the number of levels, height of the building, etc. Other data. You can even create new data using geometry features, like this is a full climatic station in the campus. I can create a polygon using this tool, and then I can select appropriate feature type. Uh, so there is no feature type for this kind. There are many feature types like land use, water body, park, hospital ground, place of worship, buildings, etc. I will simply keep it area, and then I will give it a name, full climatic station WA campus, and then you can save your data by clicking this button, and then it will ask you to for a change set comment before uploading. Created a new feature, just add your comment, and then it is asking me to add tags also. So I will add meteorological data collection, just any tag, and then I will save. And then you can add this change set comment, and then you can this is optional whether you would like someone to review your edits or not, and then upload the data. So all the changes are being uploaded to OpenStreetMap, and then you can check by logging out and zoom to the area. Like this is the feature that you had just now created. You can use this query features option and then click in your feature, which will give you information about the feature. Like this is full climatic station NWA campus with a unique ID, and then it was edited by this user, and with having it has 5 nodes. Maybe I had clicked 5 points to create this polygon. So in this way you can you can even check the history of this feature by querying. I had given the name. You can check the history, who has changed it, who has added the name. In this way you can create and add your own data on OpenStreetMap. Now let us see how to download OpenStreetMap data in the format where you can visualize the data in any GIS software, like in the shapefile format. Now you can go to this URL geofabric.de, and also humanitarian OpenStreetMap team, hotosm.org, and geofabric.de. In the geofabric.de you can check this data tab and click on downloads, and here you will find the URL to the download server where the data is derived from the OpenStreetMap dataset and it is available for free download. You can click this and you will find the data extract categorized by area, like here it is continent wise, which is Asia. It is in a different format. We would like to have it in shapefile format, say. So you can, if you go to regional, sub-regional level, then you will find the data in shapefile format also. So here you have the Western Zone, India Western Zone latest free shapefile data in the form, it is a zipped file. It has a number of S3 compatible shapefiles and it was modified only 7 hours ago. So let me download it by clicking here. Now your download of will start. Now we will check it by visualizing the data in QGIS. You can also you can also download OSM data from this website, Humanitarian OpenStreetMap. The download of OSM data from GeoFabric for the western zone of India has been completed. Now let me extract and visualize the data uh, without spending much time. Uh, I will launch QGIS from the startup menu by typing QGIS desktop and by double clicking on the application. So the QGIS which we had installed in the last session was a 3.28.15 long-term release. Now in the zipped file you will find many of uh, the shape files fetched from OSM data. Now you will find that each of the shape file is a combination of multiple files with the different extensions .shp, .shx, .dbf. In some cases there you will find .prj and .dbf. These are each of the files saves projection information, like .prj will be saving projection information, .dbf will be saving the field data, the attribute data, the database. So the one of the major drawback with the shapefile format is this multiplicity of the files, and you have to keep all of these files in the same folder, otherwise you won't be able to load the data. Now we have a better formats of vector data like GeoPackage and other formats. We will be looking at them in the during the coming sessions. For the time being, I will just add by dragging this OSM buildings uh, shapefile onto my layers panel, and you can see that buildings data pertaining to western zone that comprises of Maharashtra and Gujarat is getting loaded because it has a lot of data. Maybe it may be having many lakhs of features, uh, so that's why it is taking some time. And now you can just click on right click on the layer of OSM buildings and check on open attribute table, which will load the attribute table of these buildings. You can see that there are many features, about 8,70,457 features mostly, and you can see some of them have been marked and given the name by the user. If you are aware of any, like I think if you like, this is Gateway of India, you can check by zooming to the feature. This is Gateway of India. Now just to see the context where it is in the map, you can add base maps. Now we will be in the coming sessions we will be adding the base maps using a plugin quick map services in QGIS. For the time being, we will try to add OpenStreetMap using this option of XYZ tiles. In the browser you will find XYZ tiles. In case if you are not finding any of these panels, you can simply go to view and check the panels, and then simply check the box next to the panel, like browser panel. You can check the box, then this will be visible, and you can scroll down to find the XYZ tiles, and in under XYZ tiles you will find the OpenStreetMap option. You can simply double click or drag it into the layers panel, which will add the OpenStreetMap. You can keep it under the our buildings layer, so you can check that this is Gateway of India as marked by under OSM, and you can see the locational context, and you can see the other data sets, other building data sets. Like this one is Taj Mahal Hotel. So in some of the buildings, prominent buildings, public buildings, the names and other field data has been entered by the public, by the users. You may find some the fields are not filled up in many of the other cases in other features. So anyway, in this way you can download data from OpenStreetMap, and then you can visualize the data on in your QGIS application. Now let us have a look at few more open access vector datasets for global administrative boundaries. You can look at these four sources. Number one, natural earth. It is suited for cartographers. It consists of cultural and physical vector datasets on a global scale at different map scales, and also one raster dataset with hillshade relief, which can be used as a base map. Natural earth data can be used for preparation of maps. Then United Nations Food and Agriculture Organization's global administrative unit layers. This dataset it was updated in the year 2024. Previously, the earlier version was from 2015. Then Diva GIS. Apart from the administrative boundaries, it consists of other spatial data which can be downloaded country-wise. And then Global Administrative Areas GADM dataset, which was last updated in the year 2022, and next update will be in the coming year 2026. It is available for download as GeoPackage. GeoPackage is another format where you can store the vector data. Shapefile is quite old and has many limitations, you can only save point type or uh, line type or polygon type in a particular shape file, and also shapefile comes along with associated files. If you misplace any of the associated files, it will be difficult to make use of the shapefile. So anyway, we will see that geo package afterwards. It is a database based format which we will have a look later. These four global administrative boundaries datasets can be used for mapping purposes, for preparation of maps and for analysis of any part of the world. However, if you are doing any specific project for any particular location or any administrative boundary within India, you can go for Survey of India online vector datasets, Survey of India of online maps portal, or India Varis portal. We will download administrative boundary data layers from Survey of India online maps portal and use during this training program. You can access Survey of India online maps portal using this URL. If you are accessing it for the first time, you have to register using your mobile and email ID for registration. And once you create your login credentials, you can log in and check for the various types of data sets which are available. Many of them are priced. However, the administrative boundary database files are freely available, and you can download the administrative boundary database files state boundaries, district boundaries, taluka boundaries. You can download them in the shapefile format. Also, you can look for field verified village boundary database files. State-wise, they are available in the shapefile as well as geodatabase format. Now, this geodatabase is another format of saving the spatial data. It is actually a database or file structure which can be used for storing, querying, and manipulating spatial data. So it is like a geo package is also another kind of database. We will see some of these formats afterwards. So let us have a demo of downloading the administrative boundary database files from Survey of India online maps portal. You simply type Survey of India online maps in the Google, and then you will find this URL onlinemaps.surveyofindia.gov.in. You can check for this sign in tab where you can register if you are a first time user, or log in using your credentials if you have already registered. Now you can register using your mobile number and email ID as an individual. There is also another option if you are a government official, and you can make use of official email ID and then get the authorization from the approving authority like HOD or anyone else. and then register as a government organization. However, here we are only going to download freely available data sets which are administrative database, boundary database. Therefore, we will proceed with registration as an individual. You can give your username, choose a username, and then provide your mobile number, verify it using OTP, and then also provide your email ID and verify it, and then the registration will be completed. Once the registration is completed, you can log in using your mobile number and password. And here you will find various products. Under the products tab, you will find many of these products are charged, like topographical maps, which are in a geodatabase and shapefile format, then digital vector database in shapefile format. All these are charged. The administrative boundary database, this charged at 0. That is, it means it is freely available for download. Then digital terrain model, then georeferenced color raster, digital geographical maps, village boundary database. This is also freely available dataset which we will download. And you will also find a open series map. The topo sheets are available for download as PDFs, which we will use. We will download one of such a topo sheet, and then we will try to do georeferencing in the session on georeferencing tomorrow. Then let us go ahead with downloading the administrative boundary database. You can see that this data set is pertaining to the taluka level for entire country, talukas with headquarters, and this one for the entire country, district levels, administrative levels with headquarters. If you want to only download it for a particular state, talukas of a particular state as well as districts of a particular state, you can choose these third and fourth options. Now I will click here and I will add this will you can find the description about the product. You can add to cart and also add the district level database, just like as you do online shopping. Then you can press this place order button and press proceed for download. And both, as you can see, both of these the database are in shapefile format. You can press on request for download tabs and generate a download link. As you can see, the link has been generated immediately, and then you can click on download option, and both the files will start downloading on as in the zip files onto your system. Now meanwhile, you can also have a look at other products. Let me also add the village data files which are field verified. Yeah. So if you click on this village boundary database option, here you have the database is available. Village boundary database is available in two formats: shapefile format as well as geodatabase format. Let us download the village boundaries of a particular district. I will select Maharashtra state, Pune district village boundaries. I want to download in the geodatabase format. I will do the same thing. I will add it to cart, and then I will place the order, agree to the terms, and then request for the download, generate the link, and then download the data set, which has happened very fast. Then other things we will come afterwards, how we can download the open series free maps, which where you can download the 1:50,000 topo sheets as PDFs. We will come afterwards to this. Now let us visualize our downloaded administrative boundary database layers. Now you can extract these zipped files. And then launch your QGIS application. You go to the browser panel. In case if it is not visible, you go to view and then check the browser panel, and you know the location where you have downloaded and extracted those files. You go to the folder and then check the available shape files, which are district boundary, district headquarters, major towns, state boundary, state headquarters, and sub-district boundaries. Add all of them to the layers panel by dragging the shape files onto the layers panel. And then you can check the second I think it already has all the layers up to the district level, so there was no need to download the second administrative boundary database. One is up to taluka level and another is up to district level. So up to taluka level has all the files. So now here you can reorder your layers. You can keep all the point layers on the top, and then the state boundary layer at the bottom, followed by the district boundary layer, followed by sub-district boundary layer, and all the three the state headquarters on the top, followed by district headquarters and major towns. Now you see there are so many because we have already the major towns is active layer. It appears as a dense network of towns. You can uncheck it. Now this is the taluka level layer overlain by the district headquarters, and these are the state headquarters. You can uncheck all the point layers, and just you can visualize these layers. This is the state boundary layer. You can right click on any layer and click on zoom to layer to see the full extent. So this is the state boundary layer as per SO Survey of India. You can see the geographical context just like we did. We can add from XYZ tiles in the browser panel. You can double click OpenStreetMap and bring it to the bottom, and you can change the symbology of state boundary level layer by right clicking the layer and then clicking on properties, and then in the symbology tab you can check on simple fill, and then you change it to transparent fill and then apply, so that you will see all the state boundaries and the base map clearly. You can copy the style of this state boundary layer by right clicking and then choosing the style option, and then copy style all style categories. You can paste it to the district boundary layer by checking it and then right click properties, right click styles, and then go to paste style and click on all style categories. So it is just visualization purpose. We will see all these things. How do you change the symbology of vector data sets? How do you look for the attribute data? All those things we will see when we start working with the vector data sets tomorrow. So you can do the same thing for taluka boundaries. I will copy the styles of district boundary and then paste it to the taluka or sub-district boundary layer. So in this way you can simply visualize and check your area. Let me also add the village boundary database that I had downloaded for Pune district, uh, which is in not in shapefile format, but it is in as a geodatabase. Now in geodatabase you will not find the any file with SHP extension. You will find the name of the layer. You can simply drag the name of the layer like here under village pune.gdb. GDB is the extension for geodatabase. You can simply drag the village and put it above the sub-district boundary. So these are the village field verified village boundaries of Pune district. So if you want to do any kind of spatial analysis even at the village level, you can do it. You can check the at any particular village by clicking on this identify features, and by clicking in that feature. So this is the village name is Chikali of Tehsil Haveli in Pune district. You can check the attribute data by right clicking and then open attribute data, where you will find all the attributes. So we will see all these things afterwards, how to visualize, how to change symbology, how to work with attributes, all these things when we when we work with vector data sets, vector data. Going further, we have open access vector datasets of hydrobasins and hydro-rivers, which are extracted from the hydrosheds. Hydrosheds core layers were derived by Worldwide Fund for Nature based upon the digital elevation data of SRTM after doing the void filling and processing the digital elevation data. There are many products which are available under the hydrosheds. And these derived hydro basins and hydro rivers are vectorized polygon and vectorized line layers. Hydro basins, they depict the 12 hierarchical nested subbasin boundaries from level 1 to level 12. At level 12, highest level, we have about 1 million subbasin boundaries, subbasin polygons with an average area of about 130 square kilometers. In case of hydro rivers, they represent the network of all global rivers that have a catchment area of about at least 10 square kilometers, or an average river flow of at least zero point 0.1 cubic meters, or both. You can go to the hydrosheds portal and look at the data products which are available. You can download both hydro basins and hydro rivers data sets from hydrosheds portal. Let us have a look at it. Now let us see how to download hydrosheds, hydro basins and hydro rivers. You can go to the URL hydrosheds.org by searching for hydrosheds, and under products tab you will find many of the data products including hydro basins and hydro rivers. You can check the hydro basins which are available for download at continental scale in two formats: standard format and then customized with lakes. You can click on this standard Asia, which will download a zip file onto your system. You can then go to hydro rivers. You can check again at Asia continental scale. The data is available for download in two formats: geodatabase and as well as in shapefile format. I will download geodatabase for Asia. I had already done that and extracted both of these zipped files. Now let us visualize them in QGIS. Using the browser panel, you can locate your folders. This is my hydro basins folder, and you can um, check for the all the shape files of different levels. There will be 12 shape files, level 1 to level 12. And then you can, pressing the control button, you can select all of them, and then you can drag them onto the layers panel. Now as you can see, at the top, at the highest level, at the smallest level, that is at level 1, entire Asian continent has been categorized as one single basin. At level 2, you can see entire Indian subcontinent is under one single basin. All the rivers flowing into Arabian Sea and Bay of Bengal are categorized under one single basin. Then at level 3, all west flowing and east flowing rivers have been separated. River basins have been separated. At level 4, you can clearly identify some of the major basins like Mahanadi, Godavari, Krishna, and then Kaveri. Then if you still go further, you will find at the highest level, that is at level 12, you have small watersheds of an average area of about 100 to 150 square kilometers have been delineated. Now delineation was on the basis of the points where the river two streams are merging, then and if any of the stream has a catchment area of greater than 100 square kilometers, they have delineated it. So you will not find these these hydro basins to be readily usable, because you will be requiring the catchment area of a reservoir or catchment area of a gauge site or any other particular point where a water resources project is being proposed. So for that we will do the delineation of catchments in the coming sessions. Now let us also add the hydro rivers dataset, which was downloaded as a database. You can drag this hydro rivers entire folder, and you can check the geodatabase table and click on add layers. Again, now here you can see this has this will appear to be a very dense network, because all rivers having a catchment area of 10 square kilometers have been delineated. So if you check the attribute table, you will find that there are about 14 to 15 lakh features which are there in the attribute table. Anyway, we will when we do the catchment delineation, then also we will be generating the channel or stream network for a particular area before going for the delineation. Then also it will look similarly but for a smaller area. Now let us look at open access raster datasets. To start with, we will look at digital elevation model datasets. The most popular digital elevation, open access digital elevation data is SRTM data. The highest quality SRTM data is available at 90-meter resolution at equator from this portal, geoportal of CGIAR CSI. CGIAR stands for Consultative Group on International Agricultural Research, which is a global partnership that unites international organizations engaged in research about food security. CSI stands for Consortium for Spatial Information. Now, by highest quality, we mean that the original data of SRTM, which was distributed by NASA and USGS, it contained many no data voids, especially where water or shadows prevented quantification of elevation. So, many researchers have tried to fill in these no data voids, and many versions of SRTM data have come. Now it is the data which is available on this geoportal is version 4 SRTM 90 meter, which is void free. The data is available in the form of 5 degree by 5 degree tiles. Now, by degree, at 1 degree consists of 60 minutes, and each minute consists of 60 arc seconds. So, 1 degree is equivalent to is equal to 3600 arc seconds. And this data set, when we talk of resolution, we talk in terms of arc seconds. So SRTM has this data set has a resolution of 3 arc seconds, whereas the we will try to download the 1 arc second SRTM data set from USGS Earth Explorer afterwards. At equator, 1 degree occupies about 110 kilometers. The space between two longitudes is about 110 kilometers. Now you can imagine 5 by 5 degree tiles means about 550 by 550 kilometer tiles. Entire India will be covered by limited number of these tiles. And the data is available in two formats: ArcInfo ASCII format and GeoTIFF format with .tif extension. Now, till now, we have seen the vector data, and the most popular are used data format for storing vector data is shapefile format, which dates back to the time Esri came up with its ARC software. And we have spoken about the limitations posed by the shapefile format, which is a multi-file format actually. And also one more limitation is in a shapefile format, in a particular shapefile can have only point data or only polyline data or only the polygon data. It cannot have mixture of point data and polygon data. However, in case of database based formats like a geo package and a geodatabase, we can have multiple layers, and it is more efficient way of storing the data. They can also have raster data layers in them. Now this raster gridded pixel type data sets, most of the time you will come across .tif extension. They are GeoTIFF format. Now let us download the tiles of SRTM digital elevation data from this GeoPortal. In the address bar, type this address srtm.csi.cgiar.org. It will take you to the SRTM 90 meter digital elevation database. You can click on this tab of SRTM data, and then which will take you to the download manager. These are the 5 degree by 5 degree tiles I was talking about. You can check any of the tile and see its position. India will be located somewhere here. You can then click on the search button. So this is the tip of peninsula is being covered by this tile. So if I download 7 tiles, it will cover the entire peninsular India. So let me download these 7 tiles starting from the tip of peninsula. Let me search. So you can see the position of all these tiles, and you can download click on these download links to download these 7 zip files, which I have already done and then extracted them to these folders. Now let us try to visualize them. From the browser panel, you can locate these 7 folders and drag the raster data file with .tif extension into the layers panel. Sorry. So we have added all the 7 tiles. When we deal with the raster data in QGIS, we will see the symbology and how to mosaic and how to change the visualization, etc., to remove this blocky appearance. Uh, Now let us move to USGS Earth Explorer, which is useful for accessing many of the open access raster data, the satellite imagery. It provides access to a wide range of Earth observation data. This is the URL to access USGS, United States Geological Service Earth Explorer. Users can search for data, raster data, navigate, preview, and download via an interactive map canvas to obtain many of the data sets such as Landsat series, which is the NASA's Landsat program was initiated in the year 1972. And it consists of multispectral satellite imagery. As on date, Landsat 8 and Landsat 9 are operational. You will have all the archival data. You can access all the archival data, including the current operational Landsat 8 and 9 multispectral imagery. You will also have access to many of the digital elevation model data sets, including SRTM, 30-meter resolution and 90-meter resolution data sets. There are other data sets like radar data sets, then land cover data sets, and it has also has some commercial satellite imagery, aerial imagery, mostly pertaining to United States. Registration is required to download data from Earth Explorer. I will recommend you to create an account using this registration link. And once you create your login credentials, you can access the data and download the data. We will be using some of the data downloaded from this portal during our training program. Now let us have a demo of downloading open access raster datasets or multispectral satellite imageries from USGS Earth Explorer. You can type USGS Earth Explorer in Google, then you will find this URL earthexplorer.usgs.gov. As I said, you need to create a login ID. You can for accessing the dataset. Even without data login, you can just scroll and look for the datasets which are available. However, you are required to create a login ID because you have to download SRTM 1 arc second DEM for the purpose of catchment delineation from this portal. So if you click on this login, you will find this option of create new account. You click this, you input username and password, and then if you click continue, it will take you the second part of the form, which will ask you about some specific questions like what you intend to do with the earth observation or remote sensing data. You can fill in like you want to do some analysis area, spatial analysis for your area of interest, or you want to undertake a training program, or want to use the data at workplace. Give genuine answers in full sentences, then it will be accepted immediately. Generally, once you receive confirmation mail, you can go to USGS Earth Explorer and then log in with those credentials. So once you log in, you can have a look at this. This is the map canvas area. By default, it points out to some location in US. You can scroll the map to your area of interest, or alternately, you can define your area of interest using the tools here. You can in the first tab, enter the search criteria. One way is you can upload your shapefile or KML file, or simply if it is a prominent location, you can select this option of geocoder and select a method, geocoding method. Under the select a geocoding method, you can select address or place. Now for this for now I want to download SRTM 1 arc second DEM tiles for Pune region for delineating the catchment of Kadakwasla reservoir. So let me type Pune here. You can do it for your own area of interest, or you can follow me. as you wish. Then once it shows the result, you can click on the result, which will take you to the point location of Pune. You can also see the latitude and longitude listed here, and then you can zoom to the area of your interest. This is the Kadakwasla Dam, and on the upstream you have two more dams, reservoirs, Warasgaon and Panchir, and these are part of the Mota river system, which is a tributary of Bhima, which in turn is a tributary of Krishna river. So for this catchment, the catchment area extent is somewhat like this. I will, however, you can every time you can take the precaution of including an extended area. If you have some idea about the catchment area, you can take an extended area. This is actually the water divide. The district boundary is also the water divide. On this side you will you will see the all east flowing rivers whereas all the west flowing rivers will be on this side. So let me zoom to the extent required, or even the larger area, and then you can click on this use map. What it will do is it will create a bounding box of 4 coordinates, which you can change by clicking on them and dragging, and by even adding an additional coordinate and clearing the coordinates. It is you can just have a look and try it, and then define an area of interest. And once you finalize it, you can click on this option of data sets. In case if you are looking for Landsat multispectral satellite imagery, you can even also specify the start date and end date. As you may be knowing, Landsat imagery is available at a temporal resolution of 16 days. It is optical imagery, which is known as passive remote sensing. So you can even specify and filter out imagery having high cloud cover. Such options are also available here. As presence of cloud cover in optical imagery, it creates issues for conducting any kind of analysis, for doing band math, band calculation, for mapping of water bodies, or land use land cover mapping for any purpose. So generally we filter out the imagery which are having high cloud cover. Anyway, let us come back. You can click on this data sets. Now, under this second tab of datasets, you will find all the datasets which are available on USGS Earth Explorer portal listed out. You can check the aerial imagery and commercial satellite imagery like Iconos 2, which are available, but they are available for US region only. And under digital elevation you will find many options like this GMTED 2010, which has a resolution of 250 meters. And under SRTM there is a separate section of SRTM which you should select. And under SRTM you will find this SRTM 1 arc second global. You check this option. Now this SRTM 1 arc second at equator is equivalent to 30-meter resolution. This is the data set which has voids, which is not the kind of data set which we had downloaded from CGIAR CSI Geo portal, which was a further refined product where voids were filled, and it is available at 90-meter resolution. Here also you have a void filled data SRTM data set, but for catchment delineation we will try to start from the scratch by downloading the high spatial resolution 30-meter resolution. If it has more voids, we will see how can we overcome that. We may look at other options of available DEMs. We can use Cartodem DEM of our own Cartosat ISRO's Cartodem DEM, which is available at 30-meter resolution, which can be downloaded from Bhuvan portal. We will also see that.
So you can check other options, other imageries like Landsat. As I said, Landsat multispectral imagery, all the legacy imagery and all the collections from Landsat 1 are available for download. Landsat for the better collection is Landsat collection 2. Earlier there used to be collection 1. Now they have refined it to collection 2. And there are different levels. Then after collection there are level 0, level 1, level 2, level 3 products. Level 0 is like raw imagery, and level 1 after some geometric corrections, which is basically top of atmosphere reflectance. It gives top of atmosphere reflectance, and then after doing the atmospheric correction, you will get the level 2 products, which are basically surface reflectance products. And then level 3 products are scientific products. Like you can see, they are specific for specific purposes, like this dynamic surface water extent, burnt area product, then fractional snow covered area product. These are available, which you can make use of readily. You can make use of for any research purpose. So now we are not downloading the Landsat imagery. We will have a look at it afterwards. Now then you will also find one NASA LPDAAC collection. Now this NASA DAAC stands for Distributed Active Archive Center. There are many distributed active archive centers in US which distribute the Earth observation data and modeled data collected and processed by NASA through these distributed centers. They are available using a different ID that is known as Earth Data, NASA's Earth Data login, which you can create separately. Now, one of the distributed archive center LPDAC collections are also available in this USGS Earth Explorer. So you can find Aster Global DEM, which is another global DEM, which is as you see, this will require NASA Earth data login credentials to download data from NASA LPDAC collection. So this Aster Global DM is another popular DEM which can be used. It is also available at 30-meter resolution like SRTM, and you will also find many of the MODIS datasets. MODIS is another. There are twin satellites, Terra and Aqua satellites, and there are which they collect after the collection of surface reflectance. The products, they have many products generated, like land cover, primary productivity, albedo, glow, then vegetation, net evaporation, vegetation indices. There are many products of MODIS which are available at 500 meters resolution, mostly 500, and some are available at 250-meter resolution also. So you can have a look at all these data sets. You can explore the data sets, and you can choose you have to follow the same process of setting up your area of interest and then choose the data set. Now I had chosen SRTM 1 arc second global, and then you can click on this results button. Then it will get all the SRTM tiles which are intersecting this area of interest. There is basically, here in this case there is only one tile which is a larger one, which covers the entire your area of interest. You can see its footprint by this foot symbol here, how the extent you can see to see whether it serves your purpose or not. Suppose you want to delineate the larger Bhima basin, then you have to go for more tiles. If you want to delineate Krishna basin, then you need multiple tiles covering this region. So let me go ahead with this. How to download? You can see this button. If you scroll your mouse, you will see that says download options. You can even preview show browse overlay. Yeah, you can preview the dataset, and then you can download by clicking this download options, where you will have the dataset available to for download in three formats. We will go for GOT format. You click on this download, then it will immediately start downloading on to your system. This is just one tile, so it will not take much time. So this is how you look for your data sets on USGS Earth Explorer and download them.
Apart from the data sets which are available from on USGS Explorer, there is another set of data sets, raster data sets, which you can download from Earth data system, NASA's Earth data system. It is a comprehensive system that provides access to a variety of earth science data, not just remote sensing data, but even field data, climatic data, modeled data, atmospheric measured data. NASA acquires, archives, and distributes such data from a variety of sources, and also distributes and promotes Earth observation data acquired from other non-NASA missions. So you will require an Earth data login to acquire such data sets from many of the distributed active archive centers. You can have a look at this URL to see what are the different distributed active archive centers which are available, and you can register yourself at this portal at this URL for Earth data login, using which you can access the data sets. You can search for the data set, and also you can use Earth data also provides many tools and services that enable the users to analyze and visualize the data they access. So we will not be able to cover many things in this short session. So you can explore on your own. We will simply show a demonstration of some of the portals of DAACs from where you can access the data sets.
You can look for NASA's Earth Observing System Data and Information System (EOS-DIS) data distributed active archive centers. You will find the distributed active archive centers throughout US, like and these are the list of the centers as well as their individual portals where you can access the data. For example, this Alaska Satellite Facility is one of the DAACs which deals with synthetic aperture radar. We will find many of the radar data sets here. Similarly, here in California, this is Physical Oceanography DAAC, which provides data sets related to ocean winds, ocean surface topography, sea surface salinity, etc. Of interest to us, of hydrologists, are Land Processes DAAC, which provides data sets related to land cover, surface reflectance, temperature, topography, vegetation indices from MODIS and other satellites, other sensors. We had seen this data set available on Earth Explorer, but you require an Earth data login to download the data. Similarly, you will find this Goddard Earth Sciences Data and Information Center, GES-DISC, where you will find the global precipitation data sets, the global TRMM earlier, and now global GPM data sets are available apart from solar irradiance data sets. Then this one, Socioeconomic and Application Center, CDAC, which provides socioeconomic data in the form of rasters and also vectors. The more some like data sets like population density of population raster data sets and other data sets are available there. You can explore them. So similarly, there are many other DAACs, individual DAACs you can explore at your convenience. In the short period of time, we cannot cover the whole things. The availability of data sets, we cannot cover everything. We will see one DAAC, the Alaska Satellite Facility. This is the website portal where you will the most popular content, as you can see, is the ALOS pulsar the SAR data, which is which is available at a resolution of 12.5 meters, and it is radiometrically corrected. In future, you will find NISAR data will be become available through this Alaska satellite facility. NISAR, you may be knowing, or in case if you don't know, it is a NASA and ISRO joint satellite mission, which is meant for studying hazards and global environmental changes. This the data. This ASF will be the NISAR data hub. You can access data from here. So every such facility has many tools for visualization and downloading also. For example, in this case, in you have you can click on this get data. You have this vertex, this portal where you can search for data, and then you can give the type of the data set, and then area, and then start and end date, and then you can filter, and then you can download the data. Every portal will come with user guide, then help videos are available, so please explore as at your level as per your convenience. So you will find a lot many things. I will also show you something related to global precipitation, which comes from this GES DISC. You can search for Giovanni, GIOVANNI. Um, this gives NASA Global Precipitation Measurement Mission datasets, as well as other datasets from GES DISC. So to access the datasets, you can use the Earth data login. You can create an Earth data login by going to this URL urs.earthdata.nasa.gov, and you register yourself. For all these, even for the Alaska satellite facility and all those DASs, you will use the same login. Here you can search for giving the type of, you can even plot, you can the analysis time series of rainfall data sets you can generate by giving the date range, by selecting the region. You can there are inbuilt regions defined, including the major watersheds. Like if I look for Krishna Basin, it should be there. Krishna watershed is defined. So you can select the data set of Krishna. You can select the aerial extent. You can select the date range. You can select the type of plot, and then you can select the data set from GPM. There are many data sets which are available from Global Precipitation Mission, and then you can plot the data after selecting the data set. So please have a look at this.
Coming to European Space Agency's open access datasets, we have this Copernicus data space ecosystem, which can be accessed at this URL. You can register and then use your login credentials to access. This is the new portal of European Space Agency for accessing the Sentinel dataset. Copernicus satellite data, including Sentinels and other contributing missions. Previously, there used to be one Copernicus Open Access Hub, which is no longer operational. This data space ecosystem also provides data analytics environment. Available datasets include full archive and newly collected images of Sentinel-1, Sentinel-2, Sentinel-3, Sentinel-5P, and complementary datasets such as Copernicus digital elevation model and world cover cloudless mosaics. You may be well aware of you may have heard about these two missions, Sentinel-1 and Sentinel-2 missions. The Sentinel-1 operates in radar in microwave region, whereas the Sentinel-2 in optical region, optical and near, including the visible and near infrared and thermal infrared regions. The Sentinel-1, it comprised of two twin satellites, two polar orbiting satellites using C-band synthetic aperture radar imaging, which allowed them to capture images during day and night and all through the year, even during the monsoon period. where optical imagery cannot provide cloud-free images. Therefore, it has a very high application area. These images can be used for monitoring of floods or flood inundation during monsoon period. However, unfortunately, one of the satellites 1B, Sentinel 1B, went dysfunctional in December 2021 because of some power failure. Now they are planning to launch Sentinel 1C to replace it. Then the Sentinel-2 is the data set, the multispectral data set. The data is available in 13 spectral bands. Some of the bands are at a 10-meter resolution, most of them, and few bands at 20 meters and 60-meter resolution. They provide high resolution, high spatial resolution multispectral imagery which is available in public sphere. Earlier, the Landsat imagery is the one which used to have the highest spatial resolution at 30 meters. Now the Sentinel-2 is available at 10 meters. There are further commercial satellites which provides even sub-meter resolution, but they are not freely available.
Now you can search for this Copernicus data space ecosystem in Google and access this website, dataspace.copernicus.eu. If you are accessing this for the first time, you can register by going to this option of my account and then sign in. And then you will find the button for register, where you can register and create an account. Once you get a confirmation email, you can log in using your credentials. Now this data space ecosystems, it provides you many options, limited in a limited manner for analysis purpose. However, we will be only looking at this Copernicus browser, which is used for browsing the data sets and searching them and then downloading them. Whereas this analyze data portion tab consists of many tools, like many APIs, application programming interfaces. Jupyter Lab is one of them. Jupyter Lab, in this Jupyter Lab, you can write custom scripts in Python language and then use some analysis. You can conduct analysis making use of the computational facility offered on the cloud. It also provides a data workspace. You can add your data to your workspace and do analysis. Now for now we will be only looking at the Copernicus browser. You can see the data collections, various data collections which are available on this portal: Sentinel data, contributing missions, and other federated data sets. Now let us go to the Copernicus browser, where you can search for you can go to your area of interest by typing in your location, area of interest, and then click on the options. You can zoom in, you can create your area of interest using these tools of creating a polygon, then or drawing a line or marking a point of interest. And if you click on this show latest data under visualize tab, it will show you the latest available satellite multispectral satellite imagery. By default it is taking Sentinel-2. You can change it to Sentinel-1 also. So under Sentinel-2 and also it is taking a default value of the cloud cover of 30% for filter. And it is showing the true color composite, a natural color composite, where the red, green and blue bands are given the red, green and blue colors. This is how your eyes visualize the earth surface when you are flowing at a height. Now suppose if you are interested in marking any of the particular feature, like if you for marking the vegetation to visualize the health of the vegetation, either you can make use of index, very popular index NDVI, or you can use a band combination of false color composite, where NIR band is given red color. So here you can even see the dark portions, which are the water bodies. They clear because water has low reflectance in NIR band. You can clearly see the boundaries of the reservoirs. We can clearly mark them. So by using various band combinations, you can visualize the features, and you can do it for distinguishing various features on the surface of the earth. This we automate when we do the supervised classification. We will do it by making use of various band combinations when we come to the session on LULC mapping. Now you can also visualize other band combinations, like this one, false color, which is used for visualizing the urban area. Let us scroll to the urban area. Yeah. Then you can also there are other indices like normalized difference water index, which is used for delineation of water bodies using green and NIR bands. Normalized difference snow index. You can even have a classification map of this area, and you can even have custom index. You can develop your own custom index using these 13 spectral bands, and you can even write your own custom script or import a script. So let us search for some data set. Like I would like to have a look at Sentinel-2 data sets covering this region from say 18th January 2024 to 18th February 2024. I will select Sentinel-2 multispectral instrument. Then there are two levels, level 1 and level 2. I will select the level 2. You can change the cloud cover filter. Say I will make it 40 percentage, 41 percentage, and then you can click on this search button. So all the Sentinel-2 tiles intersecting this region will be populated here, and if by just clicking visualize, you can visualize those portions on your screen. You can see their extent only by hovering. Just by hovering your mouse, you can see the extent of various tiles, and you can see these options. There is an option for download. You can download it, the data set, from any particular day. Like this is from the Sentinel-2 instrument MSI, and sensing time 18th February. So you can download the data set. There are many other options, tools for measuring distances, for creating time lapse animations, for 3D visualization, etc. You can explore these options at your convenience.
Now coming to the open access data sets which are made available by ISRO, Indian Space Research Organization, you can visit the Bhuvan portal using this URL. Bhuvan is the geoportal of ISRO, maintained by National Remote Sensing Center, Hyderabad. Under the Open Data Archive section of Bhuvan portal, you will find satellite data and products derived from the Indian remote sensing satellite series, segregated into three classes based on satellite, theme, and project. These are some of the data sets which are available. Useful data sets like Cartosat digital elevation model version 3 at a resolution of 1 arc second, which is approximately 32 meters. And then ResourceSat, AWIPS, and LIST 3 data sets which at the spatial resolution of 56 meters and 24 meters respectively. These are multispectral imagery, and there are few more data sets.
You can search for Bowen NRSC portal in Google and go to this URL bowen.nrsc.gov.in. There is lot of information available on the portal. We are more concerned about the open access datasets. You can check this section of Open Data Archive, where you will find the categorization by satellite and sensor, theme and products, and program and projects. You can check the available data sets, like under satellite and sensor you will find the ResourceSat satellite and LIS3 and ABIPS sensors. Similarly, SCATSat1, Scatterometer, OceanSat2, OCM and other data sets are available. You can select, if I select LIS3, you will find the technical documentation, brochure and other user handbook which are available for download. And then for downloading purpose, you can select by specifying the bounding box, by specifying the lat and longitude, or you can give the topo sheet number, and the tiles covering the topo sheet will be identified, or you can individually zoom in and start selecting the tiles by looking at the background map, and or you can do it by interactive drawing. In any case, you can only download 20 tiles in a day using your account. Here you have to create an account by registering, and you can download only 20 tiles, and you have to add the remaining to the backlog. You can come the next day and continue downloading another 20 tiles, and so on. We will try to download the Cartodem digital elevation model, which is available under this option of theme and products. You select the theme of land and terrain and the product Cartodem version 3. You can also again have the look at these technical documents, and then for selection you can select by tiles. If you know the aerial extent of your catchment that you want to delineate, say again I want to delineate the catchment of Kadakwasla reservoir, then I will select my tiles. To be on safer side, I will select greater extent. You can start selection of tiles by clicking on this start button, and then individually you click uh, on tiles by pressing the control button. So I think I can download these two tiles, or even I can select more number to cover, say the upper Bhima, the entire Bhima basin I can cover. So once you select the number of tiles, you can click on stop button and then go to next. Then the selected tiles, here I have selected 8 tiles. The selected tiles will be listed. You can see the visualization by adding onto the map, and see the metadata and the topo sheet number. These tiles are as per the topo sheets, and then you can download each of the tiles. It will ask you to log in. So as I said, you can only download 20 tiles in a day. Here I have selected only few slides, few tiles, so there is no issue. Otherwise you can add them to backlog. So if I click on download, it will start downloading. So in this way you can download the Cartodem tiles. I will recommend you, apart from the USGS Earth Explorer, you can also create an account on this portal and download the tiles such as these for delineation of catchment. We will make use of both, we'll try to make use of both SRTM dataset, digital elevation model tiles, as well as the Cartodem tiles for catchment delineation in the coming sessions.
Coming to Bunidhi portal enables access to extensive archive of remote sensing data from 47 satellites, including Indian remote sensing and foreign remote sensing sensors acquired since 1986. It facilitates regional distribution of Sentinel, Landsat 8 and 9 data in India. As per the India Space Policy 2023, satellite data which is of 5-meter resolution or coarser is freely available for all users. You can access this data, download the data freely from Bunidhi portal. Data finer than 5 meters except DEM and other some other customized products. It is open for government entities after some understanding between NSIL and the agency concerned, and it is priced for non-government entities. You can also order priced products from the same Bunidhi portal. It is handled by New Space India Limited under Department of Space, Government of India. This is the link for accessing the Bunidhi portal. Now let us have a look. You can search for Bunidhi and go to this URL bunidhi.nrse.gov.in, where you will find this section of browse and order. Click on visit. Then this is the portal where you can search and download free and open access data, as well as you can order priced products. As it says, as per the Indian Space Policy 2023, satellite data of 5 meters and coarser is now free and open for all users. We will try to download list 4 data of ResourceSat 2A satellite of ISRO, which has a spatial resolution of 5.8 meters. So you need to create your login credentials for downloading the data. You can search for data even without login, but for downloading the products you need to have the login. You can search the data sets of pertaining to your area of interest. Prominent locations you can directly search by the place name, or you can create a polygon by zooming to your, the area of interest in this map canvas area by providing the coordinates of bounding box, the left most top corner and the rightmost bottom corner coordinates you can provide, or you can upload your own shapefile or KML file. I will search for the location by place name. I will search by Pune. Yes, so you can see this location coordinates. Click here and then click on this locate button. So this is the area of Pune city. Then you can specify the date range for searching searching the data sets. I will keep it as it is. Then you can make use of these filters to look for your data. I am looking for open data. Then resolution 5.8 meters, list 4. So I will select this 5 meters to 25 meters. Then imaging spectrum, it is multispectral imagery, so I will select optical. You can also see that there are other like microwave data, I think Sentinel 1A 1B you can download from here, and also non-imaging imagery are also available. Then under these given filters of open and then resolution and optical data, these are the available satellites: IRS 1C, 1D, ResourceSat 1, ResourceSat 2, ResourceSat 2A. ResourceSat 2A is the latest. I will select this. Then you also have Sentinel 2A, 2B and 2C. Then you can also select your sensor, like list 4, which is at 5.8 meter resolution. List 3 is at 23.5 meters, and ABIPS is at 56 meters. These sensors
they capture multispectral imagery in a limited number of bands. I think in list 4 you will have 4 bands. Then under products there is only one option, level 2 product. Level 0 products are always raw data. Then level 1 products are uh, geometrically corrected data. They give reflectance values at the top of, normally top of atmosphere data. Then level 2 products are after atmospheric correction you will get the surface reflectance. They are the level 2 products. And level 3 products are scientific products. Now this is the general nomenclature for if you go to even Landsat data or Sentinel data, there is the same nomenclature of levels. Now this level 2 georeferenced terrain, then themes. You can select your themes or you can skip it, no issue. If for the purpose you want to, like suppose if your purpose is mapping of water bodies, the remote sensing lecture, you were introduced to band math, making use of normalized difference vegetation index for mapping vegetation areas. Similarly, you have normalized difference water index for mapping of water bodies. There are so many indices in literature. You can also you make use of color composites. One thing is you can start with color composites, false colors composite to identify features, and then you can also make use of such band indices, and then mask out the areas which are not of your interest, and map those, like for water bodies you can mask out all the land pixels, and then you can create by water body layer by writing the expression of NDWI. So anyway, here we are only for downloading the data. So you select water resources, and then under satellite sensor, it is open direct download component, resource at 2A list for level 2 data. So you can also have a look at the advanced filter. Suppose you want to filter all the cloud cover images, like if you only want to have only those data sets which have 0 to 10% cloud cover, so you can select it. Or you can, if you want to download irrespective of the cloud, you can select this option. I'm selecting this cloud free 0 to 10%. Then click on submit. Then it will give you the results, the next tab. So for that period of October to November, these are the data sets of list 4 level 2 from resource at 2A satellite. This the latest imagery is from 30th October. You can check the extent of each of these tiles by clicking on this image extent. You take your mouse, then it and this button says image extent. You can click it here, and then it will show you the extent. Now this is this extent doesn't cover the actual Pune city. So let me check the, yeah, I think this tile will cover. Yeah, so this tile I would like to download this. So for downloading you first need to add your product to the cart, and there are other buttons like this gives information about the metadata, when was the pass, 30th October, orbit number, ground orbit number, then extent. So you can have a look, and then you can add it to the cart by clicking this add to cart button. Then it will ask you for inputting your credentials. Yeah, once you log in, there is this survey they are collecting information about from the users about their area of interest. You can select your areas of interest. Submit, and then you go to cart, this third tab. So this is added to your cart. You can click on confirm. Cart has been confirmed. So if there is any delay, they will be fetched, but here you will get direct download button. You can click on download. So you can see your data is getting downloaded. In this way you can download uh, remote sensing imagery from Bunidi portal. We will explore these products. This is raster data. We will when we go to the sessions on vector data and raster data, we will explore. We will add them to GIS software, and we will do the things like band math, mapping of water bodies, etc. We will have a look later.
Now let us see the data sources available on India Waris platform, India Water Resources Information System. India Waris was launched through a memorandum of understanding between CWC, Central Water Commission, and ISRO in the year 2008. And over a period of time, many geospatial layers were developed and the data was collated, and the platform was launched. It has now, as on date, it is looked after by National Water Informatics Center, which was constituted in the year 2018 as a central repository of updated water data as well as allied themes data. It was funded under National Hydrology Project. This is the URL through which you can access. It acts as a data dissemination platform for hosting static, dynamic, and semi-dynamic water resources, spatial and non-spatial data, and so many 130 GIS layers for the entire country through various modules. Now let us have a demo of India Varis platform.
You can look for India Waris portal. Go to this URL indiavaris.gov.in, where you will find this tab of water data under different heads: surface water, groundwater, land resources, hydrometeorological, allied themes, project, water resources project data. So you can visualize the data from here by selecting the date range and the source of data. If you want to download the data, you can come to this data download section, which is relatively new. From where you can download time series data as well as geospatial data. Under time series data, you will find data sets of time series data is not geospatial. It doesn't have any spatial component. You will find telemetry data and manual gauge data. You can download it as a various data sets like rainfall, soil moisture, water level, groundwater level, and river water level, etc. And in the geospatial data, you will find many geospatial data sets, right from administrative boundary layers, then water spread area, land use, land cover data, etc. So you will find this manual time series manual and geospatial user manual, time series user manual and geospatial user manual. You can open them and check for what are all the data sets which are available for download. So under time series data, you can download telemetry gauge data of pertaining of different stations. Data download for multiple stations is available at district level. So you will find rainfall, river water level, snowfall, temperature, wind direction, all these parameters. Then manual gauges are also time series data. Wherever it is available, you can uh, it is sourced from different data producing agencies and is published by NWIC. If you want further, as it says, if you want further information and clarification regarding the data, you can contact the data producing agency. So there are many implementing agencies of NHP which have set up many telemetry gauges. Now anyway, we are more concerned with geospatial data, and the geospatial data, you can check that you will find administrative boundary layers, district water body atlas layers, or flood inundation layers, drought affected area layer, then snow and glacial lakes, groundwater layers, groundwater station layers, telemetry stations layer. So there are many data sets which are available in vector as an raster format. Let us have a look by going to this section. Yeah, so you can check this administrative boundary layer. We have seen that we can get the administrative boundaries databases from online maps, Survey of India online maps portal. You can also get the same here. Like here you have the district headquarters, census town 2011, census village 2011, then state boundaries, district boundaries, sub-district boundary, village boundary, Survey of India dataset itself. It is available here. You can download these. These are all our vector layers. You can download them as a shapefile or a KML file or GeoJSON file. So, so when you try to download, it will ask you to state the purpose. It will not ask you to log in. There is no requirement. You can select the purpose and then specify your name and email ID and click on submit. Then the download will start. So this is village boundary Survey of India shapefile, 414 MB, a very big data layer. So you can also explore other geospatial data, um, district water body atlas, which will have the maximum water spread area of the water bodies state wise and district wise. You can download as shapefile. Hydrological layers may be of interest. You can check. Here you have the basin layers, basin polygons as demarcated by CWC, watershed boundaries, reservoir basins, reservoir region, river, this layer, river names. You can have this line layer of vector, line type of vector layer, where there are 27,575 rivers. River lines of different various basins. So these are all our vector data sets. You can also have a look at, say, land use land cover data from NRSC. These are raster data sets. You can download this data which is available for 2005, 6 to 2017 and 18. So if you click any here, the download will start. So these are all there are many layers, groundwater well location layers, which will be a point data, flood inundation layer, snow and glacial lakes. Again, this is maximum snow extent data set. So you can explore these various data sets, which are geospatial data sets, which are available for download from India Varis portal. Finally, let us have a look on this portal, data.gov.in, which is Open Government Data Platform of India, which is a single point access to shareable data, documents, um, and tools published by various ministries, departments, and organizations of Government of India. So it is all the government generated data sets which are in public domain. You may find them here, including the information which was tabled in Parliament of India as an answer during question hour. All those data sets you will find. Most of them will be non-spatial, but you may also find some spatial data set if you look for shapefile. So you can see pin code shapefile of rivers. Again, this may be from India Varis only. If you click here, it will take you to the same. Uh, you have here also you have to provide your usage type, non-commercial, then purpose, give your name, mobile, and email ID, and input the code which is seen here. Then you can click here download. Then it will download onto your system. Shapefile of airports of the country. There will be many interesting data sets in non-spatial data sets. All kinds of data, socio-economic data you will find here. Anyway, so you explore this portal too, which you may have some interesting data sets. So whatever you have seen in the previous slides, it is the traditional or conventional way of doing geospatial analysis. You go to the data portal, you register, and then you log in. You download the data sets for your area of interest, or you download them and then clip them. You reproject them, and you will find many of the data sets in different formats. And you will try to visualize them in GIS software like in QGIS, and then you try to do analysis for one scene at a time using GIS software, or you can use a programming language like Python to write a program to do analysis of multiple scenes. You can do that. But still, if you want to do analysis over a long period of time, and you want to make use of many scenes of data, first of all, to download so many scenes of data, it will take a lot of time and resources. And then once you have the data with you, you have to prepare the data, and because the data is in different formats, data preparation part will itself will take lot of time. And once you have the data ready, the computation power which is available with your system will be limited to do the kind of analysis covering at larger scale over a longer period of time. So we have this platform called Google Earth Engine, which makes all the open access data sets which we have seen till now, apart except for the Indian remote sensing satellites data which is not available in the public data catalog of Google Earth Engine. All the data sets are available on Google Earth Engine data catalog, and you can write a simple code in the code editor, which is an integrated development environment of Google Earth Engine, and then communicate with the Google Data Center, which hosts the data sets in the cloud, and which also provides you the computational power for doing any kind of analysis. All the data sets are analysis ready data sets, and you can do the analysis, and it will send you back the results in the form of charts or map layers, which you can display, which will be displayed on the your interface. So you can have a look at this short video.
You can check the link to the video Meet the Google Earth Engine from the YouTube channel of Google Earth in the previous slide. You can also visit this URL developers.google.com/earth engine to see the documentation, and you can sign up for accessing the platform using your Google or Gmail account. And then you will find in the Earth Engine data catalog is very extensive, consisting of all the Landsat, Sentinel, and MODIS, multispectral imagery, and other data products of MODIS, and then digital elevation model data sets, land cover data sets, weather and climatic data sets. There are so many data sets which are available. Open access data sets are readily available in analysis ready manner in the Google Earth Engine platform. I just wanted to introduce you to it, but one step at a time. This training program is on introduction to remote sensing and GIS using QGIS. If you are interested in Google Earth Engine, you can attend our introductory training course on Google Earth Engine and its applications in water resources management. That's all from my side for this session on open access data sets. Thank you very much.